So if you want to use it, you can. Yes, yeah. It's off right now, so just turn it. That'll turn it on.
I'm only going to use it if we start.
So we have it as a, what? Yes, yeah, you're good to go.
Good?
Yeah.
Okay. Anyways, so most of you probably know how a wind turbine works, but the different parts of the wind turbine, obviously you have your hub and your blades, then you have the nacelle, which holds the gearbox and the generator, and that energy flows through the gearbox to the generator, and that's where it switches to electrical energy that runs down the tower and the cable to your transformer and then out to your grid. And so looking furthermore at the actual blades themselves, there are different types of wind turbines, different shapes and things, but looking at your typical fan style wind turbine, you have residential and commercial. So if you're from Norman, you might know that Berkeley here in Norman manufactures the residential wind turbines. And the white ones there are made of epoxy and fiberglass. And then the black ones are actually carbon fiber, fiberglass, epoxy, and then they have a foam insert inside of them. And then there's a steel piece at the bottom. You can kind of see where it's kind of rounded. It's actually like a round steel piece. And then these are made by Vestas, and that's actually out of Colorado. Those are more your commercial. And they're made of a little bit more material, so they might have wood and several different layers of foam actually go into those different sizes and things. So those are the different types of wind turbine blades that we're looking at. So from the beginning to now to the end, after they come out of the build, they'll go to what's called like a wind turbine blade grade. Or some companies have actually started taking them and cutting them up and grinding them up and putting them in concrete as aggregates and fillers. So that kind of keeps them repurposing them and keeping them out of maintenance.
Okay, so the question then comes up, what is a composite? So we wanted to make sure we knew what we were dealing with from the beginning. And a composite is when you've got two different materials, and when you mix something with something else, it becomes a new product or something that takes on maybe attributes of both and adds a new concept in with it. So it's a composite material can be defined as a combination of two or more materials that result in better properties than when the individual components are used alone. So we work with several different types of materials, as you can see. Carbon fiber is a very flowy, very soft, very malleable type of a fabric. But when you mix it with an epoxy, it becomes very rigid. You guys are familiar with burlap. Burlap's kind of a rigid, itchy, really heavy, fibrous material. It also becomes very rigid. So those are just kind of examples of what we have as our composites that we fall back on. So the process that we went through when we made our layups, and there's some really important parts to it. We did what we would call a wet layup with the vacuum assist. You can do a variety of different methods and a variety of different techniques. This just happens to be the technique that we used, where we would put down a layer of our epoxy first, layering up onto what we would call pill ply, a really strong polyester material that gives the fabric some tooth, and that tooth is enabling future layers if you want to add to it in the future. But we would put up our first layer of material onto the peel ply, and then depending on how many layers you want 2, 3, 4, 8, 10, you would continue to add epoxy and add your material to it. But the big important part is two things. A, you've got to make sure that you get all your air out, because if you've got air pockets, those are voids, and those voids are weaknesses that would be found in your different plies or your composite. The other thing that you got to make sure that you don't have is you don't want to have too much epoxy. There's a pretty good ratio, and then depending upon the technique, but 50-50 ratio, 60-40 ratio is about where you want it. Too much epoxy, it becomes very brittle, and it eliminates some of the characteristics that you'd be wanting with the strength of the fiber itself. So, as I said, we went through all these different procedures. We would take the material, we would put it into the vacuum assist, and then we would let the vacuum suck any air out to try to eliminate any of the air bubbles that would be found inside of our layup. We let that run for about 5 hours, then we'd shut it off because the epoxy's begun to cure, and then we'd have to let it sit. This was kind of a problem for us in our project because we would work, And then we get to a point where we couldn't do any more with the layup because we had to let it cure. So we had to kind of come up with a secondary part that we were working on, and we'd start getting ready for the next day in our downtime while it was curing. We did a little bit more research and a little more reading and kind of a little bit more prototyping in that time. So, first question is, can we reduce the life cycle analysis of wind turbines?
And can we use other materials that are not as harsh or damaging to the environment?
And then our last question was, can we use other materials that offer a more sustainable, greener alternative? So after doing a little bit of research, we went to Bergen. We got to be able to see the wind turbines that they had, and we came up with this idea: what if we used a more sustainable product to make the wind turbine? And we got to looking at what natural fibers are available. So I jumped in the truck and I drove to the local Joann's fabric store, and I asked the girl, I need all of your 100% natural fiber materials. And there were some things that you would think were available, there were some things that were not. The one that we really wanted was hemp. Hemp is a fiber that we know comes from the marijuana leaf from cannabis, and it's expensive and it's hard to get depending on where you're at in the country or depending on where you're at in the world, but it is actually recognized as one of the strongest materials out there. So we went with our second best. We went with jute, which is burlap. You guys are familiar with potato sacks or burlap bags. And we went with linen, which is from flaxseed, and we went with a strand of muslin from cotton. We've got all natural, no dyes, no bleaching. We just went with as basic as we could in what we were looking for. I wanted to get some silk. I wanted to test silk, but you would not believe how hard it is to find 100% silk products without having to be able to put them in. So we went and we decided we were going to buy some of these different sustainable materials, and we started making up layups. Here's Alyssa doing our first layup with burlap, and it ended up looking like a piece of plywood, as you can see in that sample.
And so here we start preparing for the actual testing of the materials. And so we cut them into what's called coupons. And those are 228 millimeters by 16 millimeters. So it's like 9 inches by 16 millimeters wide. And then we put little carbon fiber tabs on the end of them for the tensile machine to be able to grip it. And the picture at the bottom, you can see each coupon setting up. And so when you glue the carbon fiber tabs onto, you want to make sure that they're on there well. So they clamp for 24 hours each. And then once we finally got most of them done, we started doing our testing on those.
So our testing was rather interesting. We were both surprised at some of the things that happened. I think Alex helped us out. Alexander came up and she stepped up to the plate to help us go up to the lab to do the testing of these materials. And then Dr. Nanny stepped up and he helped us go and take photographs of the different types of fabrics. We were able to get some measurements on how big these fibers actually were. It kind of gave us a little bit more perspective on how strong these things were. But we can see that linen on axis had an average of 61.5 megapascals, which it stretched out quite a bit, comparatively speaking. But it had some strengths to it, but it was very flexible.
And then this is the flaxseed linen. So the picture's off to the right there. The top one is showing you the raw material, and the bottom one is showing you after the test. So just one of the coupons that's been fractured. And so the average strength of that one is 50. This is actually our least amount strong, the smallest strength. So that was pretty interesting. And the pictures over there, the red line show you the different width of different parts of the material itself.
Okay, so on the burlap, it was kind of interesting because if you're familiar with burlap and you've ever looked at it, you know that each fiber is made up of multiple little bitty tiny fibers. And that was one of the things that's beneficial with this picture. As you can see, they look like little plastic ropes that are putting it all together. But when it broke fairly consistently, but each fiber would break as an individual. And the nearest we can guess is that the reason this line is so jagged is because it could break. The other thing that we're not sure about is the optics. On each of our coupons, we had to put a little black dot because we had this laser that would look at these two little black dots and would measure the distance between them. And it would do a check, and it would do a check, and it would do a check. And as this thing was elongating and as it was stretching, we're not sure if it was reading other black specks that were on the piece of jute, or if it was reading the actual black dots that we put on it. So upon further discussion, we decided maybe in the future we might need to actually put a apparatus onto the actual specimen that we could measure that way instead of doing it only optically. But burlap measured in at 35 megapascals.
And then this is the fiberglass. So this is one of the standard materials used in wind turbine blades. And it came in at 135 megapascals. And you can see the fractional line over there. Just pretty straightforward. We kind of had one big one that kind of broke differently than the others. So you can kind of see that jagged up there. And the rest of them are pretty consistent upon failure.
One of the things that we noted, and we had outliers that we would either throw out or discard, but sometimes when they have this huge differentiation, we would wonder, was there something wrong with the fiber that we weren't able to see upon inspection? Was there more epoxy in that spot, or was there less epoxy in that spot? Were there anything that we needed to take note of? And we tried to take note of any defects that we could see in the samples themselves. But one of the things that we did as well was we actually made these small coupons, these little chips, that we actually would weigh out compared to a raw piece of material. And that would give us an idea of how much epoxy was actually in each sample. And that would give us our ratio. Is it a 50-50 ratio? Is it a 60-40 ratio? Or what? Making sure that we weren't getting too heavy in the epoxy. So carbon fiber. Carbon fiber is the standard that everybody uses for everything, and there's a reason for that. Carbon fiber is very consistent, and you can buy carbon fiber in a lot of different quantities. You can buy 2K, 3K, 4K strand carbon fiber, and they're probably coming out with more and more and changing it every day. But carbon fiber had an average strength of 630 megapascals. That's strong, okay? That was very, very strong. In fact, we had to change the head out on one of the machines with moving over to the carbon fiber because the initial machine stopped at 5,000. Is that right? 5,000, and we had to change out to a heavier head because it just couldn't give us enough weight on the stretch.
And then here's just a graphic of our overall test results with all 5 on here. And so you can obviously see that the orange is going to be the carbon fiber, the gray is the fiberglass, and then the other 3 are down here. So the jute is kind of hidden, it's the yellow, so it actually stops right here. It's kind of hard to see. And then the muslin and linen actually stretch out farther as far as string goes, and the others, which is kind of interesting, they have a little bit of flexibility with them. And then, like Charlie had mentioned earlier, in between our wait time, we were like, what if we could make a mold and create our own small scale wind turbine blades? And so we 3D printed, we found a file online of like a commercial size blade scaled down. And we 3D printed several of them. So the black one was printed in the Pierce lab, and then Charlie actually printed the blue one with his 3D printer. And then we used those to make a mold.
We didn't want to mess the black one up because it's actually really, really pretty. It looks like satin. But and the printing went off, and we wanted to decide how can we replicate this, because we wanted to make our carbon fiber or fiberglass or jute blades, and we wanted to make it reproducible, and we wanted to make them as consistent as we possibly could. So we came up with an idea to make a mold. And what we did was I took our carbon fiber or layup, and we used a product that's very similar to plaster, and we made a double clamshell mold of our blades. And then I lined it with duct tape just to take up space, because I realized that we didn't want to make it any heavier or any thicker than what the design already was on it. So we laid up our blade into the plaster molding, and we made a mold out of that. And then with that mold, you want to talk about this one?
Yeah.
Okay.
So we actually used spray foam after we put the layers we needed to into the mold to make a foam insert for our own miniature blades, and we have one right here.
This is actually the last foam blade that we made, and it's a fail. It's not a good blade because I ran out of material. I ran out of foam when we were making it, and you can see that it's kind of hollow inside. This would have been discarded, but I kept it just simply because I wanted to have something to show in the end. But then we took this and we used this as our core for putting our carbon fiber or our fiberglass or jute or whatever the material that we wanted to use on that. So what we did was we took carbon fiber and we took the burlap and we did our wet layup, and I learned a little bit as I did this. The more times I did this, I kind of figured out a better procedure for doing this. First time I did it, we laid it up on the outside, one strip at a time, building it onto the actual piece of foam. That was hard to do because I'm constantly, holding and changing and manipulating this, and it didn't really work out the way that I wanted. So I figured out a better way, and that was doing the layup, putting the foam in the middle and picking it up like a taco and wrapping it around the end of it, around the outside of it, forming it into the peel ply, and then setting it into a vacuum bag. And this was the jute one that we did. I think it came out pretty well. So we would go through the process and put it through the vacuum, and then we take it out and we finish sanding it and cutting it on a grinder to get it to the actual shape that we needed. So the question that we asked, can we make our wind turbines out of something other than carbon fiber? Yes, we can, but you need to understand, and this is the truth of it, carbon fiber is the Mike Tyson of the fiber world. It takes out everything. We have tried a variety of other materials, and there's a lot of research that we want to do further. I have been reading up that there's a fiber that comes from a banana tree that is supposed to be on par with or as strong as hemp, and just shy of the strength that we would find with carbon fiber. But the question comes up, how much of that material do you need to be able to make a sustainable fabric or textile to be able to make a layup?
And so Enel is a company we got to go tour during our 6 weeks here, and they are a green power company, and along with them and other companies, there are actually several companies doing research on this as well, finding different results and things. Enel specifically was looking at fabrics as well, like what type of fabrics can we use to make more sustainable turbine blades. But I tried to look for their results and I couldn't actually find it. It was just like an article heading saying they're doing that research, so it's kind of hard to see what they found so far.
Okay, so that's our conclusion. But before we stop, I want to thank everybody. I want to thank the National Science Foundation for allowing us to be here and to be able to participate.
The RET with OU and ECU.
Dr. Nanny helped out a ton. Alex helped out a ton. Dr. Umugante helped out, and Dr. Walsh gave us some moral support there in the lab as well. I want to thank my school for giving me the opportunity to be able to come and do this and represent them.
Yeah, same. They definitely helped get here.
Okay, so thank you all. If you have any questions, we can ask away. Oh, one final thing. Okay, we wanted to decide, can we make something that would be kind of a normal object that would be made out of a sustainable material? And we decided we wanted to make skateboards. So we took jute and then I went to Goodwill and I bought the biggest pair of blue jeans I could buy. And I cut it up and I made 8 plies of jute and 4 plies of denim. And I made this wonderful skateboard that I'm not quite done with it yet, but it is made out of 100% sustainable materials. It would be recyclable in one capacity or another. But I wanted to do this just to simply show that your imagination kind of limits you on what you want to do with these types of materials. And we had a great time doing this.
Yeah. So I actually took the strongest material and the weakest material from our results because carbon fiber was so much stronger. And then I took it with, I got muslin. So I used muslin and carbon fiber, but the carbon fiber is kind of expensive, so I actually did a mix of carbon fiber and fiberglass, so it wasn't using up a whole lot of carbon fiber to make mine to see. And I actually stood on it and it held the weight. I'm just not allowed to ride skateboards right now, so I didn't ride it. But yeah, it's pretty cool. So thanks for helping us make these. But yeah, thank you guys.
Thank you.